All right, good afternoon to everyone. Welcome to our live session after a very long while. Um, so you guys are here freely. You guys here are here because of your own choice. Now, hopefully, this means that you want to learn. So, with that in mind, whatever we are discussing, and I hope if you have a question, you're going to stop me right there and then and ask me your question. If there's something that I explain and you don't understand, you are going to tell me that you don't understand and for me to explain some other way for you to get it clearer, because you're here to further your understanding of IT, to better yourself in IT. So, are we in agreement with that?
Yes, sir.
Great.
Yes, sir.
Great. So, the more you guys respond, participate, the better for you guys. Alright. So, to get us started, I want to take like about 10 minutes to do a recap, a quick recap of the majority of things that we covered so far. And then we're going to get into 1.6 and 1.7 and 1.8. So, to do that recap, I also want to show you guys a software that you guys can actually use. So I'm gonna give you like some useful tips in creating projects and so on. So this software is called Xmind, and Xmind it's basically used to for brainstorming. So if you don't know what brainstorming is, it's a method of coming up with ideas, and it can also be used to create diagrams, like for example what you're seeing right now. And another example could be like this here. It could be used to create diagrams like this here. So if you also want to know how to create diagrams like that, we will be looking at that also. So the software, you can actually, the software's name is Xmind, and I'm actually going to be using it for our quick revision. So you can use it on your phone. Notice there's a mobile version, there's a desktop version where you can download the software and run it on your computer, or you can use the web version. So obviously you need to sign in first. So I already signed in. I signed up for an account. I used my Google account. I signed in, but I'm gonna use the web version. So after you signed in, you can go to the web version. So you don't have to download anything, and it's gonna take you to this page here, and you're gonna go to New, and you can basically select the layout as to how you want to create your brainstorming chart. So if you want to create a chart with any one of these patterns here, this is where you can choose that pattern that you want. Let me see, which one should I choose? One that is going to be simple to follow. I'm going to choose the very first one. I think that one is simple to follow. So, and I'm going to choose my color, red. Yeah, I'm going to stick with red. And I'm going to select create. Great. So now that I am in my Xmind software, now here's where I can start designing. So what I'm going to be putting into this now is the basically the table that I would have created for you guys. I'm actually going to put it into that brainstorming it's brainstorm chart. So in chapter 1.1 we looked at what is a computer. So in the very central topic, I'm gonna put computer. So that's our central topic there, computer. Now for that computer, we looked at some definitions for the computer. We looked at what is the IPOS cycle. So you guys are clear on what is the IPOS cycle, right?
Yes, sir.
Anyone that is not clear about it, that wants me to go through it one more time? Going once, going twice, sold. So I guess everyone is clear with the IPOS cycle. So the computer now. The computer has two main components: hardware component and a software component. So if we go back to our chart, we can, I'm going to delete this main topic and that one, and I'm going to put hardware as the first and software as the second. So that is our two main components here. When I'm finished with this diagram, I'm going to send it to you guys so you can have it also. So that is the two major components for a computer. Now on the hardware, we have the five major components here. So I'm going to put that in also. So under hardware, I'm going to select that. So remember, we also learned how to use the software. So I selected hardware, and I want another branch. So I want a subtopic. I'm gonna make it a topic. No, topic is there. So I guess I gotta select this here and make it subtopic. Where did software go? Software. So under hardware, we have CPU. What else? We have input device, output device, memory, and storage. So I'm going to need a few more subtopics. Not out there for now. Subtopic, subtopic, and subtopic. So this is going to be input devices, output devices, what was the other one? Memory. And then we have storage media. So that would fall under hardware devices. So on the CPU, we further have subtopics on the CPU. On the CPU, you're gonna have your CU, which is your control unit, and your ALU, your arithmetic and logic unit. So that covers CU and ALU. And in line with the storage media, you're gonna have your storage device. So I'm gonna put that as no, I'm actually gonna make that a slash storage media slash devices, because we're gonna have subtopics underneath it. Great. Are you guys following so far?
Yes, sir. Yes, sir.
Great, great. So we also looked at this term here, peripheral device, which refers to any device outside of the CPU. Now software has two types: system and application software. So we're gonna go under the software branch. We're gonna select subtopic. I'm gonna put in system software, and I'm gonna select back software, another subtopic, and I'm gonna choose application software. So I have two branches there for software. Now under the system software, we have two software. We have the operating system and utility software. So on the system, I'm going to add a subtopic. I'm going to put operating system and add another subtopic. That's going to be utility software. Yes, that's correct. So those are our types of software. Then we have application software there, and we already looked at what is information technology and what is communication technology. Alright, so those are the major topics for this chapter here. Is there any part of this chapter that anyone is confused about, that you want any clarification on? What is a software? What is a utility software? What is communication technology? What is a peripheral device? Anyone? Everyone clear on it?
Yes, sir.
Alright,
Yes, sir.
great.
Yes, sir.
So we're going to move on to chapter 1.2. What did we learn in 1.2? We learned mainly that an input device is getting data into your computer. And there are two types. There's manual and then there is direct data entry. So I'm going to enter that into my chart. So under input device, I'm going to add a subtopic. That's going to be manual input devices. Manual input devices. And then direct data entry devices. Let me spell out these here. Central processing unit, control unit. Right, so under our input devices we have those two types. I think I can save this file, right, as an xmine file, and let me see if I, because you guys can put in the devices later on. Let me see, can you open an xmine file? Oh, open local file. So what I'm going to do, I'm going to save this file, and I'm going to save it as both as an image and an xmine file. So when I click save as xmine, what you guys are going to do is you guys are going to this same page here. You're going to click on this icon here. You can barely see it, but it's here. Click on it and it says open local file. So when you click on that now, you're going to search for the file that I'm going to send you, that xmine file, and you're going to open it, and you're going to add the additional devices. So for example, the keyboard, the mouse, the document scanner and all of that, you're going to add them correctly under whether they're in manual input or direct data entry. Now not all of you need to do it, because maybe one of your friend can do it and then pass it on to you. So this chapter here, we looked at all of those devices. They fall under those categories there. Let's see. And we looked at the advantages and disadvantages in the end. Alright. Any questions on input devices before we move off of this chapter? Like what is OCR, what is OMR, MICR? What is a smart card? Clear on everything? Alright, I'm going to assume you guys are clear. So we're going to move on to output devices now. Now, output devices, there are two types of output. So this is chapter 1.3. There are two types of output. We have soft copy output and we have hard copy output. So we're going to add that into our chart now. Output devices. We're going to add soft copy and hard copy. So those are our two types of output there: soft copy and hard copy. So soft copy refers to, remember we looked at those terms: hard, anything that deals with the word hard, hardware, hard copy, it's referring to something physical. And soft, software, soft output, soft copy, it refers to something that is digital, something that is not permanent. So in this chapter we looked at different types of displays, different like what is LCD, what is LED. Let's see. So for soft copy, we are going to have hard copy. We're going to have printing devices. Is that what we have? Yeah, printing devices. And then on the printing devices, we have the different types of printers that we looked at. We have impact printer. We have dot matrix printer. We have, okay, well, we have impact, and that falls under. So another tip with the software is that you can actually click and drag. So if you notice, I needed to move that one there. So you can click and drag also if you need to move it anywhere. So I can click and drag and put it at the end of impact. And then I can click back on printing devices and add non-impact. Is it non-impact? Yeah, non-impact printer. Non-impact printer. And under non-impact, we're going to have inkjet. Is it one word? Yeah, it's one word. Inkjet printer. And what else do we have? We have laser printer. We have thermal printer. And then we have 3D printer, but we're gonna put that outside of the category because they can basically be impact and non-impact. Because remember the difference between the two? It's basically whether they're touching the paper or not. And then we also have plotters. And for both plotter and 3D printer, they can both be based on design. They can either be impact or non-impact. It all depends on how the person would have developed it. For audio, soft copy, we're gonna have audio devices. Remember the sound we're looking at. The sound is soft copy. If the speaker, the radio, if it loses electricity, we lose the sound that we're gonna get from that. Under audio devices, remember we're looking at output. So we're gonna have headphone. We're gonna have earphone and headset. Remember there's a difference between all of them. The difference is basically size. Headset is a larger headphone is a larger one that goes over your ear. Earphone is what goes into your ear, and headset is basically a headphone with a microphone. Are you guys following so far?
Yes, sir.
Yes, sir.
Any questions from anyone?
No, sir. No questions.
Alright, so we added all of the audio devices. We added the printers. Um, printers. So for soft copy, we're gonna also have display. We're gonna have display devices, and on the display, you're gonna have types. So on the types, we're gonna have liquid crystal display, and we're gonna have light emitting diode. Now, this part here, you guys can do some more research and you can add more types of displays, because there's also organic LED. So for example, organic light emitting diode as another type of display. So light emitting diode is going to be LED, and organic light emitting diode, that's going to be OLED. And then for your phones, LCD. If you're using an iPhone, you're actually going to be using LCD. And if you're using a Samsung phone, you're actually using AMOLED. AMOLED. Can't quite remember what AMOLED stands for. AMOLED. Let's see. Active matrix organic light emitting diode. And you guys can add more if you want. Great. So what are some other displays now on the display device? So those are the types. So we're gonna have examples of displays. So we're gonna have your monitor. What else? This monitor needs to be plugged in, or the laptop. Your television. Whiteboard or smartboard. Whiteboard. We can just name it smartboard. That is what we usually call it. Is smartboard. A projector, a tablet. So a projector, and even your phone, the display in your phone. So we're gonna say mobile devices, because that basically covers your laptop, your phone, your tablet, the display. Those would be mobile devices there. And let's see, we looked at pixels and different aspects of the display. Great. Are you guys following so far?
Yes, sir.
Yes, sir.
Great. So we've just completed our chart on those 3 chapters there. So we're now going to chapter 1.4. So in 1.4 we looked at what is this memory now. So remember, memory is what your computer uses to store instructions. So our types of memory, we have RAM, random access memory. So we're going to go back to our chart. And where is memory? Where is memory? Memory is at the bottom here. So we're going to click on that, add a subtopic. RAM, random access memory. And then we have ROM. Hafiz says ROM and VRAM. ROM is correct. Read only memory. And then we have hybrid. That's hybrid memory. Good. So remember, RAM and ROM, they both have their differences. They both have their advantage and disadvantage, RAM and ROM. But hybrid combines both of the the advantage of RAM and ROM. That's how we have hybrid. Are you guys clear on that though? The advantages of RAM, the advantages of ROM, these types of memory?
Yes, sir.
Anyone wants us to go through it?
Sorry, Kanye.
Alright. So, RAM. What is RAM? To understand what is RAM, remember our computer has a CPU. And we call this CPU the brain of your computer. The CPU is responsible for processing. Remember that IPOS cycle? You input data. So this is going back to the IPOS cycle here. You input data, you input, you process, and then you get the output. So processing is making a change to the data. Your CPU is what processes your data. The CPU is what makes the change. Now, where does the CPU get the data from to make the change? It's going to get that data from memory. Or we also call it RAM. Or we also call it main memory. So those are the 3 names that we give it. So your data is going to be stored inside of here. So for example, your Word document is going to be in here. Your Paint is going to open and be inside of your RAM. Whatever software is open on your computer is going to be stored inside of your RAM. And when your CPU has to process that Word document, it's going to send it over to the CPU like this here. And the CPU processes it and makes any changes or calculation that is needed. So that there is the purpose of RAM. That's the purpose of memory. To give the CPU the data that it needs to process. Was that clear?
Yes, sir.
Great. Now, so inside a computer, you're going to find 1 or more memory chips called RAM. We call it random access memory. So in your actual computer, if you search for RAM, hope you don't get it. Yeah, I had a feeling this would come up. Oh, yeah, so not this one here, not this one here. We are looking for this one here. So these green chips here, this is the RAM inside of your computer. This is the memory inside of your computer. So anytime you open your desktop, or your laptop, you're gonna notice some chips like these here. The longer ones are for desktop. If you notice how long this one is, this one here is for your desktop. But if you notice, this one is a bit shorter. This one here is for your laptop. So this is what your RAM looks like, your memory. So that there's going to be in any computer, even your phone. What if you change your RAM? Will anything happen? You can't change the RAM. Nothing will happen. But just that you'll have to change it when the computer is off. But other than that, nothing will happen to your computer once you change it. Samsung phone RAM. Samsung motherboard. So even on a Samsung phone, for example, like this one here, the RAM might actually be one of these small chips. Because this what you're seeing right now is the motherboard of a phone. This is the motherboard of a Samsung Note 3. So we can say Samsung Note 20 motherboard. So this is the motherboard here of a Samsung Note 20. And I think it looks like this big white square here on the top right. This could be the CPU. And some one of these small black chips could be the RAM or the memory. So it doesn't matter what device it is. They're going to have the same structure. They're going to have a CPU. They're going to have memory, which is going to send the instructions to the CPU. Now, as I said, these RAM, they hold temporary operating instructions for the computer. So, as I showed you, the Word, the Paint, and any other software, we normally call them the instructions for your computer. Even Windows 10, your operating system that you have running right now, is currently in RAM. It's currently in memory. So that is how your CPU is running Windows right now, because it can see Windows 10 inside of your memory. So any program that you're using will go into memory. So this is the place where the CPU receives the instructions and the data to basically carry out its job. Now, so that's how the RAM functions. What is the advantage of the RAM? Now, the advantage of the RAM is that the computer can access the data immediately because it's actually relatively close by. A motherboard. Your RAM is usually close by to your CPU. And it can access the data very quickly. So, why did it cut off the diagram, the image? Alright, so if you notice this diagram here, let me use, I'm looking for a better one. Alright, so now, alright, I guess this one is a little better because it's showing us the information. Good. So where it has processor socket, that's where the CPU is located. So this white rectangle you're seeing, that's your CPU. Notice where it indicates memory. That is where your memory is going to be inserted. So if you notice how close it is, it's only like a few inches away. Now, whereas, remember your other data is going to be stored on your hard drive. So this SATA that you're seeing on the left hand side, that is where your hard drive is going to be plugged into. So if you notice these two blue at the bottom left, these two blue ports at the bottom left here, that is where your hard drive is going to be plugged into. And remember, your hard drive is going to be connected with a cable, so that adds even more length or more distance from the CPU. So all of that distance can limit how quickly data can get to the CPU. So that is why the data is first transferred to memory and then it goes to the CPU, because the CPU can get it quickly from memory anytime it needs it. Can I change the CPU in the laptop? Yeah, you can change. You can change your CPU. You can change your RAM, but it all depends on if how the manufacturer develop it. For example, the same phone, um, the same Samsung phones. If you look at it, obviously you cannot change the and then there's compatibility also. If you look at Samsung phones, the CPU and the RAM, they're soldered onto the board, so you can't, unless you really know how to dissect it. Basically, you won't be able to take it off. But some persons have done it. They have replaced the CPUs on those devices, but it's not for a normal everyday person to do. So most desktop-based computers, their board is gonna come something like this here, what you're seeing, and they allow you to change the memory, they allow you to change the CPU, and everything inside of it. So it comes something like this here, like these here, and you can change the memory, you can change the CPU, you can change the GPU, and so on. But as Africo mentioned, there are different sizes of CPU. We call them sockets. So if you ever search for a CPU socket and you go to Wikipedia, you're going to see a wide variety of sockets. So we have sockets for so these blue that you're seeing is Intel and the red is AMD. So if you notice, there's a wide variety of sockets that we have here. So you can't just buy any random CPU and put it into any board. It has to basically match up. Yeah, AMD and Intel, they're both different and they have different pins and so on. Each socket has a certain amount of pins. So if you search CPU socket, this is what a CPU socket looks like, and the CPU has pins on it.
Excuse me, sir. I have a question.
Go ahead.
This is not to deal with the topic, but you know how Microsoft Word it's asking, like if it asks you to renew your plan, does it ask you annually or it's random?
It depends on how long they would have given you the subscription for, because like normally when you buy a brand new laptop, it might come with maybe a 1 month subscription, maybe a 1 year subscription. It depends on how much they give you. And then after that expires now, that's when you're going to start getting the message to renew the license. Sometimes right away, they might lock down the system, but sometimes it might take, takes a little more longer time for them to lock down the word and from restricting you to do anything with it.
So, sir, like, how do you renew it? You have to put in a PIN?
You would have to actually pay for a license to get it activated.
No, sir, because it's no, like mine is asking me to put in a PIN.
Mm-hmm.
So,
a pin or a key?
yes, sir, key.
Good. So yeah, so that's what I'm telling you. When you buy the license, you get a key that you'd have to enter, and that key is what will activate the license on the software.
Okay, sir.
So if you go to like Microsoft Word, why am I typing Word? Microsoft Office, and you get Office, they would usually tell you what are the costs. So these are the plans, and they would give you a key, um, not a key, yeah, key, a license basically, and you enter that license, and it basically activates the program back for you. Alright, so going back to what we were talking about, got we sidetracked it a lot. What were we talking about? We were talking about how the information in the RAM is accessed immediately. We were talking about because of how relatively close by it is. And then we went on talking about CPU compatibility. I was showing you that some CPUs have pins on them, and some of them have different amounts of pins with different layout and so on. And this is how the socket would normally look. So you have to, if you're going to replace them, you have to know which CPU you have, which socket you have, what memory you have. Even for memory has, so the same RAM that we're looking at right now, there are different types of RAM. So you guys can take down this information also. There are different types of RAM. Where is Wikipedia? Normally, right, random access memory. So RAM. DRAM, SDRAM. Why is it not showing me what I want to see? Alright, I'm not seeing what I want to see, but basically if we go back to our mind map, we can add subtopic on the RAM. So we have different types of RAM, like we call them DDR, and then from that now, where did it go? Let me add a few more. We have DDR2, then we had DDR3. So these are types of RAM that came out over the year. We're currently at DDR4, and I think DDR5 is already out, but it's a bit rare right now to see DDR5. But we're at DDR4 and DDR5 right now in terms of types of memory. So we're looking at what is this memory once again. So we said it how we can access the data in memory almost immediately. So remember the distance is not that far, so you can access it almost immediately. So that's why we put the data in RAM. Now, so that's one benefit there. Now the disadvantage is that RAM is volatile. What volatile means is that you are going to lose the data if you lose power. So that's the second point to remember there. Volatile means you are going to lose data if you lose power, because it's only working unless it has power to the computer, to that system. So if there is no power, you won't be able to have any of the data that is being stored in RAM. So RAM depends upon power in order to store its data. So that is the advantage and that is the disadvantage there. Are you guys clear on that?
Yes, sir.
Yes.
Now, ROM. what is ROM? ROM is basically to have some data inside of it, and is going to be stored as instructions for the computer. We learned about the BIOS. So the BIOS mostly use the ROM. So for those that cannot remember, we talked about having a motherboard, and on the motherboard has a BIOS chip, which is basically a ROM chip, and it basically checks all of the devices, the CPU, the memory, the hard drive. It checks everybody. It says, are you okay? Are you okay? Are you okay? And then it looks for the operating system. Remember we looked at booting? So that's the BIOS. That's the ROM chip. So this ROM chip now is going to store the information inside of it. And but what is its advantage? Its advantage is that it is non-volatile. So it is the opposite of RAM, which is volatile. This one is non-volatile, meaning it doesn't need electricity to keep its data. It can keep its data without electricity. Where are the types of memory? Give me a second. There were supposed to be types of memory. I think that was taken out of the syllabus. User interface type. Yeah, I think that was taken out of the syllabus. Types of memory. But under ROM, there are actually different types of memory. So the disadvantage with ROM though is that, because I'm not seeing it mentioned here, the disadvantage of ROM, the disadvantage with ROM is that you could only enter the data one time. So you could only write the information to ROM, this ROM chip, one time. So it's kind of like a CD. If any of you ever created a CD before and you added some music to a CD, could you have made some change to that CD? Anybody ever did that though? You ever added music to a CD? Or y'all never?
No, sir.
Never had that privilege?
No, sir.
That's sad.
Sir, have you done it?
Yeah, I'm that old.
Okay, sir.
I when I was young, CD is what we had to use to get music, because we didn't have phones back then that we could have store music on, and so we had to use CDs. We had our computers, yeah, but if you wanted portable, you would have to use like we call it a Walkman. Anybody knows a Walkman?
Yes, sir.
So a Walkman is basically a CD player. So we had one of this here, but Walkman is actually the brand. And so basically a CD player, one like this here. So this is what we,
Oh yes, sir. I've used that before.
yes, this is what we used to use in the past to play our music. And if we didn't have one of that, we had what am I looking
Oh,
for?
cassettes, right, sir?
Yeah, the cassette.
Yeah, I just used it though, but not really. Like more before when I was younger.
So I had a nice one when I was young. I had one that had a microphone, and I could have recorded audio onto the cassette. So what I used to do is, because back then it wasn't that easy to download music like how it is today. So what I used to do is something like this one here. Not exactly like this here, but it had a microphone attached to it. And what I would do, like if one of those movies are playing, like what, like Tarzan, Spirit, or those cartoon movies, and those soundtracks came on, I would actually record the soundtrack and store it on the cassette. So when I want, I would just play back the cassette and I'd have the music. Yes, so that's how we used to have music in the past. Not in the past. That was like what, 2010 or before? Yeah, that was before 2010. Yeah, so we're talking about ROM. So ROM, you could only write the data one time. So types of ROM. Okay, I guess I should put in this information here also. So SRAM and DRAM. So let me make a branch here. This is gonna be DRAM, DRAM, and actually all of these fall under um, DRAM, if I'm correct. I think I'm correct. I'm gonna check it back later. Video 3, video 2, and then there's SRAM. And for ROM, we are going to have PROM, EPROM, and EEPROM. Which stands for Programmable ROM. And then there is EPROM, which stands for Erasable PROM, which basically means Erasable Programmable Read-Only Memory. And then we also have EEPROM, which means Electronically Erasable Programmable Read-Only Memory. So, as I was telling you guys, the disadvantage of ROM is that you can only write information one time to ROM. Just ROM I'm talking about. And PROM, I think PROM is also that you can only write it one time. It can be programmed by the user once. Yeah, you have the information here. So I'm actually going to send this link so you guys can have it also. So if you want the information, so you can take down all of that information too. So PROM, you could have only written the information once. Now what if you wanted to make some change to this ROM chip? That is when you had to use a EPROM. So the EPROM, it can be reprogrammed. So you can erase the data. But notice, to erase the data, you have to use ultraviolet light for EPROM. So EPROM, to erase the data, you have to use ultraviolet light. And that is why EPROM has electricity, electrically. So this is electrically. I have electronically. Electrically. Good. So that is why this one here is called electrically, because it means that the data can be erased electrically. So you don't need the ultraviolet like how EPROM needed the ultraviolet. So ROM is just a chip that can store data. We call it ROM because the company is going to store the data. Now PROM, it means that you can program it now. You can write something to it, but it's only going to be one time also. So now you have the chance to write something to it. Now EPROM, you can write something to this ROM chip, but you can also erase what you write. So it's like if you have a flash drive, you write, you erase, you write, you erase, and so on. But you're going to use ultraviolet to erase the EEPROM. And the EEPROM, the same writing and erasing, but you're going to use electricity in order to erase the data. This is actually the first time I've heard of mask ROM. Mask ROM is a type of read-only memory that is masked off at the time of production, like any other types of RAM. Mask ROM cannot enable the user to change the data stored in. Okay, I think this is a more higher form of ROM. So it's mainly PROM, EEPROM, and EEPROM. You guys are gonna focus on. Any questions? Alright, Hafiz.
Sure, Hafiz, I have a question. Oh,
Yeah.
you're looking at the thing.
Sir, say you bought a RAM and is bigger than the socket in the motherboard. Is there an adapter for those? Actually, I think there is, because there actually is an adapter for desktop to laptop, or is laptop to desktop. So if you search for a RAM adapter, so say for instance you have a laptop based RAM and you have a desktop, then you can take that laptop based RAM and put it inside of this adapter here, and then you can put it in the desktop. But I'm not sure you can cross between the different types of DDR. So remember I was mentioning the different types of DDR, DDR 2, 3, 4, and 5. I'm not sure if you can cross. I think I heard somebody mentioning the other day that you can yeah, I think it's possible. DDR5 to, yeah, it's possible. Because I remember hearing about this the other day. So a DDR5 to a DDR4 adapter. This exists because remember I was telling you guys that DDR5 is still relatively new. So we don't have much systems out here with DDR5. So we mostly have DDR4 right now. So persons, when they have this DDR5, they might want to convert it to DDR4, and then it would work inside of their system. What's the most powerful memory? Basically the latest version. The higher the version, the better. That's why we're constantly improving in the version. So the higher the version is always going to be the better one. Any other questions? Big to small. So, good question. I was thinking about it just now. I don't think so, because remember your laptop won't have the space. That might be the problem. So, desktop to laptop RAM adapter. No, it doesn't seem that exists. Because remember your laptop already has a limitation with space. So they won't have anything like that. It's going to be from laptop to desktop, not desktop to laptop. Alright. So that is RAM, that is ROM. So the disadvantage was basically you could only write once. That was the disadvantage there of ROM. So the hybrid now is going to combine the advantages. So the advantage of being immediate with accessing data and the advantage of being non-volatile. So hybrid memory Recently, as memory technology develops, the line between RAM and ROM has become blurred. So now several types of memory combine features of both. These devices do not belong to either group. They're called hybrid memory. They can be read and written as desired like ROM, but maintain their contents without electricity like ROM. So flash memory is a variation of ROM device that is typically used to store data. So that's how we end up with hybrid, and it's also called flash memory. So if you guys notice that, um, open back this here. So hybrid, we call it flash memory. And I'm pretty sure you guys know about your flash drives and your solid state drives. So that's SSD. So those are examples of flash memory. What are some stuff hybrid memory they're using? Well, it does give you two examples there. Hybrid memory is your flash drive and your solid state drive. So they're used in computer for storage. Any other questions? Alright, so that's the types of memory there. Do you guys want us to go through the representation of data, or are you guys clear on that? Pcie slots. So to know what is a Pcie slot, we're going to need to have a look at the motherboard. We'll look at the same image. Yeah. So this same image here, I'm going to send the same image. If you notice, you have the CPU, you have the memory, and remember I said SATA is your hard drive. Even notice BIOS is here at the bottom. Now notice you have PCI. So PCI or even AGP, those are slots that you use to add additional devices to your computer. So for example, if you wanted, say for example you wanted a network card. What is a network card? Back in the past, sometimes your computer did not come with this port on it. So the Ethernet port that you guys plug in your internet connection to your laptop. In the past, some laptops did not even come with this port, and some desktops, they did not come with them. So what we had to do, we had to buy that port as extra. So you would buy it as a card. So this is what we would call a PCI card. And you take this card now and you insert it into this slot here. So that is how we ended up with PCIe. PCIe is basically a more advanced version of PCI. So it's much faster than PCI. So PCIe slot. So these are the variations of them. So we have PCIe by 1, PCIe by 4, by 8, and the largest one we call them by 16. By 16 is at the top here in the middle, the very top. And at the very bottom we have PCI. So they're just additional ways to add more features to your computer. So say for example a graphics card, because this I'm pretty sure this is what some of you are thinking about. So your graphics card, so if you want to add a graphics card to your computer, it's going to use a PCIe slot. to connect to that computer.
Excuse me, sir.
Go ahead.
The part where you were showing the PCIe, not the slots. Before that, sir, there was this part on the no, not there. When you were searching on Google.
Mhm.
Yeah, right there. Sir, you see those little small things that look like battery? What exactly are those? Because I remember, like, when they come off from different parts, I used to, like, tear them off from the board that I was on.
They're called capacitors. So it's an electrical device that is used to process electricity, and depending on how they're used as a part of the circuit, they carry out different function. But they're called capacitors.
Alright, thanks, sir.
Mhm. When you get into science, I think when you do electech, you're gonna learn that they're basically used to store electricity. They're actually like small batteries, capacitors, and they store electricity, but they're not used to like storing for long periods of time like batteries. They're more for like short periods of time of storage, and they're also used for um, refining the electricity, like making it pure, making it clean. Because electricity can be unclean, impure, and the capacitor can be used to make it pure. Yeah, I was asking, do you
Do
guys?
something new today.
Very good, very nice. You guys want us to go through this part here? Or you guys understand how data is represented?
Sir, please go ahead.
Go into it? Alright, good. Hafiz, what are some hybrid stuff? PCIe from power supply to GPU. Hafiz, what's your last question? PCI from power supply to GPU? What do you mean? Alright, well, Hafiz gathered his thoughts. So we're actually gonna end this chapter here. So we're gonna go through how data is represented, and then we're gonna end off with this chapter. So next week we're gonna continue from 1.5 and see up to where we are going to go. So how data is represented. Now, the first thing you need to understand about computer, your computer is only seeing zeros and ones. This is all your computer is seeing all the time. In no specific order. It could be something like this here. It could be in any specific pattern. Any pattern. But the fact is, your computer is only seeing ones and zeros. Any computer, any digital device, it is only seeing ones and zeros. And you should know that is the binary system. Correct? You learned that in maths, right?
Yes, sir.
Good. So your computer uses the binary system. So all it sees is ones and zeros. So we have to understand now, how does our computer represent all of those ones and zeros? So the paragraph says everything that the computer does results from the turning on and off of different combinations of microelectronic switches called transistors or bistable devices. The word bistable means that it has two states. It's either on or it is off. Bistable means two. It has two states. Either it is on or it is off. So we know what a switch is. All of you have one in your room. And the switch either turns the light on or it turns the light off. There's no middle ground. There is no third option. It's either the light is on or the light is off. Doesn't matter if the light damaged, the light working, it's still going to be either it on or it's off. So in electronic devices, we have an electronic device called a transistor. And a transistor is also called a bistable device. Why is it called a bistable device? Because it is working like a switch. So think of a transistor just like the switch inside of your room. Just like how you can press the switch and say it is on, it is off, a transistor switches electronically. You don't have to go and physically press it and say this is off and this is on. It will do so electronically, and it's working just like the switch in your room. The transistor is either going to be in an on state or an off state. You guys are following on how a transistor works?
Yes, sir.
Yes, sir.
So your computer and especially your CPU is actually made up of millions of transistors. So if you type in how many transistors in a CPU, notice here in the Intel CPU we have 55,000. But notice as we get more advanced, so transistor count, so we started off at 2,000, 3,000 and so on, but as we get more advanced, notice we're now in the millions. 228 million. We're now in the billions. 1.4 billion. This one here, I think this one's the largest. Apple M1 Max. I'm sure all of you know about the CPU. The Apple M1 Max. This CPU here. Let me get a picture of it. This CPU, where is it? They're not giving me a proper representation of it.
So I think you have to type in CPU additionally because
Alright, good. Yeah, very good. So this is the Apple M1 Max CPU that you're seeing right now. That is inside of the Apple computers. And if you notice how many transistors it has, 57 billion transistors inside of it. So this small chip here that you're seeing, that is inside of this small MacBook computer, has 57 billion transistors inside of it. And that is actually how computers work. That is how they are working all of the time. So what do they do with all of these switches? What do they do with all of these transistors now? Well, these transistors are used to indicate on and off. Because remember, they're switches. They indicate on and off. So the off and on states of the transistors, they represent the zeros and ones in binary. So when it is off, so when the transistor is off, it's going to be a 0. And when the transistor is on, it's going to be represented as a 1. So that is how your computer knows the binary system. That's how it functions as the binary system. Because when the transistor is off, a 0 is going to appear. And when another transistor is on, 1 is going to appear. So that's how it gets that sequence of 1s and 0s. Because it's going to go through these lines of transistors. And it's going to see whether it is on, whether it is off. and it sees the zeros and ones. You guys following so far?
Yes,
Yes,
sir.
sir.
Great. So that's how your computer functions, using those zeros and ones with the transistor. Now, the zeros and ones, we call them a bit. So a single zero and a single one, we're not talking about the combination of the two. We're talking about just this bare zero here. We call that a bit. And this one here, we call that a bit. So tell me, this these series of zeros and ones, how many bits are here? This box at the bottom here, how many bits are here?
10.
10, sir.
10. So that we count it. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 bits. And that's what we refer to as bits. A 0 or 1 is called a bit. So when you have a combination of them now, the total of them is how much we call as the amount of bits. So if we had, like how we have 10 zeros and ones here, that is 10 bits. Now, important to remember, bit is a shortened word of binary digits. So the same binary, so binary digit, we shorten it to bits. Now, a bit, it is the smallest chunk of information, the smallest piece of data, because you cannot go smaller than a 0 or a 1. So that is how we have, that's why we call it the smallest piece of data, because it only is a 0 or a 1. So, how does your computer work now? What your computer does now, it takes those bits and processes them. So the more bit it can process, it basically means the faster it will work, the faster it will compute. So, and the more memory it can access. So the bit, if you notice what Hafiz typed in the chat, he's talking about 32-bit and 64-bit operating system. That is one correct application of it. Your operating system has different versions. Your operating system can have a 32-bit version or a 64-bit version. So, as we just learned, the more bit your computer can process at a time, it means it's going to be faster. So that is why we moved away from 32 bits and we're now at 64 bits. So if you want to know what you're currently working on your computer, you can go to settings and then go to system and then go all the way to the bottom to about, and it's going to show you I have a 64-bit operating system. So that's settings, system, about, and if you notice, it tells you other information also. What is your CPU, how much memory you have, and it tells you what is the bit of operating system. So remember we said the more bit, so the more bits, it's right here, the more bits a computer, a processor can use, the faster it will work, the faster it's going to compute. So that's why we're currently at 64 bits and we moved away from 32 bits. Are you guys following so far?
Yes, sir. So what really intrigues me is that just like how there are doctors that study the body, there are computer science who study computers to know how exactly they understand this binary system, which
Yes.
leads to the development of quantum computers.
Yep.
We're advancing.
Yep,
Well, it's amazing.
it is. And very technical also, because that's what I'm currently doing. So it goes really in depth as to how computers work, and it's a lot of information. And Hafiz is asking what is product key. Product key is basically the key to your computer. Where did you see it? Yeah, product ID. I think this is my license, I think. Which technically I'm not supposed to be showing you, but there it is. So what else? So we talked about, I showed you guys an example. So when this book was published, they were talking about the i5 and the i7 for Intel. And those CPU had 27 million transistors. But as I showed you guys, we have up to 57 billion transistors inside of CPUs today. So lastly, how do we represent data? So it's better to use a table. Data representation. No. Data sizes. Yeah. It's better to use a table to understand this information. How to reinstall the operating system. Yeah, your operating system needs a license. So that's what the product key is for. The product key is your license. Good. So based on this table here, as we just learned, a bit is basically a 0 or 1. So we call that 1 bit. Now if we take 4 of those zeros and 1, doesn't matter which is 0, which is 1. If we take 4 of it, we're going to have a nibble. Now we don't normally come across nibble, so that's why they have the word rare here. We don't normally use nibbles. We normally byte. So we take 8 bits and we get a byte. So when we combine 8 zeros and 1s, we get what we call a byte. So that's how we represent 8 bits. Following so far?
Yes, sir.
Now, when we take 1024 bytes, we get what is called a kilobyte. And it basically increments that way by basically 1,000 every time. So you basically add 1024 to the data size that you have before. So if you add 1024 to byte, let me see if I can draw on this thing. It's not allowing me to zoom. Alright, let's go back out. Could I copy and paste into Word? Yes, I can. Paste it again. I can. So I'm going to draw this. Yeah, so what I was saying, you take 1024 and you add it to what is the data size before. So in this case, it is byte. So 1024 byte, the next level is going to be a kilobyte. Now you add 1024 to kilobytes. That's what you have here. So 1024 kilobytes is going to be a megabyte. So each one of these sizes, if you say 1024 of it, is going to take you to the other, the next data size, basically. So 1024 byte is a kilobyte. 1024 kilobyte is a megabyte, and 1024 megabyte is what we call a gigabyte, and it keeps going on. Terabyte, petabyte, exabyte, zettabyte, yottabyte, and so on. What uses yottabyte? I don't think anything uses it at the moment. I think we're currently at petabytes, because petabyte is so large right now. We're not even at the stage of exabyte and zettabyte. They're just there to represent the data, but we actually don't have. Um, I'm sure you guys know about hard drives, and you would know about 512 hard drive. So 512 hard drive. You guys would know about that, or even a 1 terabyte hard drive, 1 TB hard drive. So you guys would know about that also. But going into the stage of petabyte, exabytes, and so on, I think we're currently. So if you search largest hard drive in the world, so the largest hard drive, if you notice, is only 20 terabytes. And what persons have to do to reach the stage of petabytes, because remember they're at terabytes, they're at 20 terabytes. I remember we have to reach 1024 terabytes to reach a petabyte. So we're merely at 20. So what persons would have to do, they have to combine a set of 20 terabyte hard drive in order to even reach a petabyte. So we're not even at the stage of petabytes yet. 60 terabytes, 14 terabytes. So we only barely passed terabyte in terms of data size. Alright, so one last thing before we go. How do we get this 1024? That's something else you need to understand. How do we get that 1024? Well, the maths is here. Basically, we're doing powers of 10. So it's 2 to the power of 10. So we're going to do it right here. If you multiply, so it's basically 2 by itself 10 times. So 2 times 2 is going to be 4. 2 4 is 8. 2 8 is 16. 2 16 is 32. 64. 128. 512. And then 1024. So if you notice 512, notice that 512. So that is why when we have data sizes, you normally see them as 4, 8, 16, 32, 64, and so on. Any of you ever noticed that?
Yes, sir. Like when you go into your storage, you see 32 GB.
Exactly. So any phone you would get, any laptop, any tablet, you can always notice it has these specific numbers when it comes to size. It's either going to be a 4 gigabyte, a 8 gigabyte, 16. For your computer, it's going to be maybe a 64, a 128, a 512. But if you see 1 terabyte, it's basically a 1024. So basically 1 TB. So this is how data is represented. It's in multiple of 2's, not multiple, power of 2's. And that is why you don't see data size like 5.2 gigabytes or 28.6 gigabyte. You don't see it like that. It's always in these power ranges here, because that's how the binary system is represented. Alright, any other questions before we close off? So what if it's 480? Very good question. Why would you see 480? Remember I just said that you're going to see in those powers. So you're going to see 128. You're going to see 256. I actually missed 256. And you're going to see 512. Now why would you see 480? Well, what actually happens is that when it comes to storage, you don't actually get the full capacity. So that is why, any of you ever noticed, like when you have a flash drive, and the flash drive is 8 gigabytes, you might get like 7.6, or even your phone, if your phone is 32, you might get 28 gigabytes. Any of you ever noticed that?
Also, because it needs extra space to run, right? To let the device work.
It's that, and also it's a bit on the technical side. what actually happens, say for instance, this is 32 gigabytes of storage. What actually happens, we have to do something called formatting. So format basically structures the storage in a way that it allows you to put data on it. If you ever search for file formats, storage, file format, um, is that the right thing? Hard drive file formats. Good. So these are some examples here. Have any of you heard of FAT32, exFAT, NTFS? No? Well, these
No,
are...
sir.
Okay, great. Well, these are methods of formatting your storage. So like, if you go to your storage, and like when you right click on it, and you go to properties, notice here it has file system NTFS. So you can check your flash drive, you can check any device that's connected. You check the properties, and it shows you what's the file type. So any storage is going to have a file type. And what's going to happen is that when you format it now, you format a storage for that file type. A part of it is always going to be reserved, or not even reserved, it's always going to be unable to be used. I can't remember what was the exact reason why. But because of the formatting, a certain amount of it is unable to be used. And the larger the storage is, the more of it is unable to be used. So say for instance, this is just a rough example. Maybe you have a storage like with about, say this is about 14 terabytes. Maybe this unusable part is 1 gigabyte. An entire gigabyte is unusable from this 14 terabytes. So it always happens for any storage. Whenever you format, it makes a certain part of the storage unusable. So that is why when you have a 512 storage, you might only see 480 because the rest is being used for something else. Or it's basically unusable. Any other questions? Can your PC make or produce Wi-Fi? Yeah, that's what we call hotspot. That's what we call the hotspot option. So,
Sir, does it actually work?
yeah, it works. I just use it when I'm in school.
Oh, okay, sir. Can your mobile device use it as well?
Yeah, your mobile device can use it also, and it's also called hotspot. So, when your device is connected to internet connection, whether it's data or Wi-Fi, but some devices, when you're connected to Wi-Fi, you can't hotspot that Wi-Fi. It doesn't allow you to hotspot the Wi-Fi. Some devices, but my phone actually allows me to hotspot Wi-Fi. I think it depends upon how much antennas your phone would have. That would determine if your phone can hotspot Wi-Fi. But usually, when it was first created, hotspot was mostly for data. So you would take the data signal and they would output it as Wi-Fi. And that's what they would call as hotspots. But today, because we have so much access to Wi-Fi, we would hotspot Wi-Fi now. So Wi-Fi to Wi-Fi. Yeah, so your computer can use it. If you check like right here where you see the time on your computer, because I'm on the other screen, you're gonna see the notification part. And then you can see a bunch of settings, and there's mobile hotspot right there. I think even when you go in settings, go to network. Yeah, mobile hotspot is right here also, and you can set your Wi-Fi, set your password, and so on. Ethernet. Ethernet is the physical connection, the physical internet connection. So Wi-Fi is your wireless connection, and Ethernet is the physical ports that you're gonna have connected with a cable. These are things you're actually gonna learn um, either at the end of the toward the end of this term. When we're finished with all of these um, chapter ones, we're actually gonna get into networking. Um, so all of these things you guys are gonna learn later on. When we're finished with the fundamentals of hardware and software, we are going to get into no, not information processing. Yeah, we're gonna get into computer network. So where we're gonna talk about all of these, everything dealing with networking, how to connect to the internet, what are the different devices, and so on. And then next term, we're gonna learn basically about how to be safe on the internet, how to protect ourselves while using computers and so on. Since you work at GTT, can you change the Wi-Fi modem router? Change it like physically to another one?
Question. Sir, do you have any recommended virus protectors?
I use the one that comes with Windows 10. That is Microsoft. Um, yeah, the same one that comes with your computer. That comes with Windows. I use this one. I don't download it. I used to use the free version of Avast, but um, recently Microsoft Defender got a little better. It's equivalent to Avast right now. I did some research the other day, and it's almost equivalent to Avast, and those are the virus protection. So once you're safe,
Okay, sir.
once you're safe, not safe. Once you're careful with how you're using the internet, how you're browsing, and how you're clicking on stuff, um, this should be good enough for you. But like if you need more protection, like if you know that when you're on the internet, um, you usually be clicking on random stuff and going all over the place, then it would be recommended to use an antivirus. So Africa mentioned McAfee, there is Avast, there is AVG, any one of those would be good enough. But the paid version is what you're going to look for to get more protection. The free version is just like if you're going to use this here once again. Any other questions? If I can change a router, yes, I can change a router. It's not that difficult to change. Unplug and swap. Alright. Okay, good. So next week, we're going to continue from secondary storage and beyond that. So if you guys don't have any questions, remember I'm going to send this file here for you guys, so you guys can have access to it and continue it. Remember to, what you can do, add in the examples of manual and input devices, and when somebody does that, maybe they can send it back to me also, so that I can have it. And there was something else. Anybody remembers? Something else. Oh, I said you can also add in more types of displays. You can even add more information to this chart here. It's for your benefit, so you can always
Sir,
use it as well.
have you heard of Team Viewer?
Team viewer, yeah.
Oh, okay.
I used to use it in the past. Have you used it?
Yes, sir, I do.
Okay, good. Um, I used to use it like how I'm home right now, and I want to connect to my computer in the lab. I used to use it control my computer in the lab. Hafiz wants to know is TeamViewer. TeamViewer is a software that allows you to control another person's computer. Obviously, you gotta install the software on the other person's computer. So it's not like you're hacking the person's computer. The software has to be installed on it, and you can take control of the person's computer and use it. So, like my example, my situation, the computer in school, I could be at home and using that computer at home, transferring files, um, using it like if I'm actually there. All right, so can you sync? So I can sync. Basically, yeah. No, it's not really used for that. It's more of just controlling the computer. Like if you were there physically in front of the computer. That's all. So instead of physically being there, it's like you're there virtually. Alright, if you guys don't have any other questions on anything we looked at for today, we're going to close off here for today. Enjoy the rest of your weekend.
Thank you, sir, for taking your time out of your schedule to come and help us.
You're welcome.
I second that. Thank you, sir.
You're welcome.
Hi, sir.
Yeah, goodbye.
Bye, sir. Thank you.
Bye, sir. Thank you.
You're welcome.